Welcome to Setting Course, an ABS podcast where we're charting the future of the marine and offshore industries. I'm your host, Brad Cox, and today we're talking about efficiency. As we've discussed before on the show, the evolving regulations in maritime are driving the industry toward alternative fuels and reducing emissions. Beyond the fuels, energy efficiency technologies, or EETs, are emerging as a way to not just help tackle those compliance challenges, but also enhance operational efficiency. Today, we're diving into the EET ecosystem with Air Lubrication system developer Silverstream. We'll get into a little more detail about what exactly Air Lubrication is and how it helps ships later on. But first, I want to welcome Silverstream Sales Director Oliver Woodard to the show. Thanks for joining us, Oliver.
Hi, Brad. Thanks for having me. It's an honor.
And joining me here in the ABS HQ is Jessie Wilson, manager of the ABS Houston Sustainability Center. Thanks for being on the episode, Jessie.
Thanks for having me. I'm excited. This is my first podcast.
So, kicking things off here, I already mentioned the regulatory environment, but it seems like EETs could have a bit more payoff beyond compliance. So, Oliver, what are the driving forces behind EETs like air lubrication? Are they purely regulation related, or are there other factors at play here?
Thanks, Brad. Efficiency is not a new concept, certainly not to shipping. It's good for business. And EETs, like air lubrication, reduce emissions, they save money, they reduce fuel burn, they're reducing unit freight costs for owners and charterers. So none of that has changed. But what has changed in regulation is that regulations shifted from technical scores like EEXI, CII, EEDI to enhanced regulations that now place real commercial implications on emissions and what you emit and what you're burning. And that's happening very soon. So low carbon fuels, where available, will undoubtedly be more expensive. There's no getting around that due to technology readiness, due to availability, competition with other industries. I could go on. Burning them may be compliant with GFI, but at a far greater cost than your regular ton of VLSFO today. And ship owners and charterers who have no option but to stick with what's available or what they know, a $500 ton of VLSFO today is going to very quickly turn into $1,500 per ton of VLSFO. So conventional fuels or otherwise, the cost of burning fuel one way or another is going to dramatically increase, improving the return on investment for any credible, proven EET. So that's what's driving from a regulation perspective. But if we look at transport economics, tech like ALS can enable more transport work for the same emissions. So improving fleet efficiency also brings flexibility to the timing of any fleet renewal decisions. It's a good time to be looking at improving your fleet efficiency, that's for sure.
Right. We actually had a recent episode talking about mitigating the high costs of methanol, and it would seem EETs have a big role to play in that. So, Jessie, what's the landscape for EETs look like today? And are the technologies a stopgap for middle-aged ships that might have less compliance options, or do they have a longer-term potential?
Definitely agree with some of the driving forces that Oliver had mentioned. From an ABS perspective, we can broadly categorize EETs into three groups. Off-the-shelf options that are more mature technologies that are already commercially available and widely adopted across the industry. Midterm solutions that are approaching readiness and gaining traction for near future implementation, and long-term innovations. These are including emerging ideas, currently in research and development, pilot stages, and early stage cross-industry concepts that could shape the future for the maritime industry. The off-the-shelf EETs are particularly valuable today because they help optimize the existing fleet, which has an average age of nearly 15 years. Given that we can't replace the global fleet overnight, improving current assets is a critical step. These proven technologies are not just temporary solutions, they're also forming the foundation of the next generation of ship designs. While alternative fuels are certainly gaining momentum, integrating modern EETs is equally important in the journey towards net zero emissions. There's still a lot of uncertainty around the future availability and types of fuels. That's where EETs come in. They serve as enablers, bridging the gap and supporting operational flexibility regardless of the fuel type that's used. Ultimately, EETs offer ship owners adaptable tools that can be tailored to their specific vessel types and commercial strategies, making them a key part of both the transition and the long-term future.
Yeah, thanks, Jessie. So the EET space is pretty broad. There's hull form optimization, hull coatings, wind propulsion, propeller upgrades. Focusing in on air lubrication for now, Oliver, what exactly is air lubrication and how does it help ship owners improve efficiency and meet that compliance that we've been talking about?
Air lubrication, like the Silverstream system, is a drag reducing technology. It's an off the shelf mature technology per Jessie's categorizations. It uses a carpet of micro bubbles to reduce the skin friction of the flatter bottom of the ship. So we're putting bubbles underneath the ship to make it more slippery, reducing the drag and therefore reducing the amount of power the ship needs to maintain a constant speed. Or at constant power, the ship can go faster with the technology switched on. So from a technical perspective, having a proven, mature technology like air lubrication, it will reduce the emissions intensity. So your scores are going to improve. It can also reduce the amount of engine power limitation you have to apply by virtue of, for the same power, it can go faster. And we are seeing ships attaining speeds of 0.5 a whole knot faster for the same equivalent power with the system switched on. That's significant. But in the new world of GFI-based, well-to-wake-based fuel regulations, emissions regulations, EETs aren't changing the type of fuel that you burn, but they certainly do take the sting out of the compliance costs. In reducing the amount of fuel that you burn, you're reducing your exposure to the associated emissions penalty. And as we can see, those penalties are only going to increase. So adopting those technologies early is going to help you in the longer term.
So, Oliver, how has the industry's appetite for air lubrication evolved over time? And you mentioned the knot difference, but what have the results been for ships using the system as far as like fuel savings?
Today, air lubrication is the most widely adopted energy efficiency technology after you get past your more conventional hydrodynamic fins, ducts, propeller boss cap fins, etc. There are around 650 commitments to air lubrication alone, and that's order book and existing fleet. It's come a long, long way in the last 150 years. And that's right, it's not a new technology. It's been known in literature for about 150 years. But Silverstream was the first to commercialize in 2014 and has quickly grown to the largest ALS provider with 120 installs and about 50% market share. Attitudes have improved. Admittedly, at the beginning, there was limited interest because in 2014, fuel prices were low. There was a low focus on emissions and there's certainly no tax on them. Different ALS solutions have come and gone. Some of them have given rise to skepticism on the technology, generally around real world performance and in-service support. So as an ALS pioneer, we've spent many, many years improving the tech readiness. It's now a mature solution and attitudes have improved. Our differences in air delivery, performance credentials, the validation of those with class and with other independents and in-service support are increasingly being recognized by owners and charterers. And that's really positive because I think anyone that's been curious enough to dial into this episode might have thought that all air lubrication is the same. And whilst this isn't a sales pitch, I'm very happy to answer offline to anyone that wants to know more about those differences. Today, the technology is considered standard in LNG and it's very widely adopted in container ships. We see penetration in multiple segments as an ALS provider. So the maturity has come a long way and it's a ready to go technology for today. And I think attitudes are starting to reflect that. Savings speak louder than any of that. Ships that have installed our system are seeing up to 10% reduction in fuel and emissions intensity. The amount depends on vessel size, flatter bottom area, speed and draft. If the vessel has large flatter bottom areas, traveling at relatively high speeds and relatively low drafts, you're at the upper end of the savings range. That said, even smaller vessels or vessels with smaller flatter bottom areas are achieving around 5% net fuel and emission savings. So it really does move the dial when you think that owners and charterers have taken advantage of the low-hanging fruit, perhaps in voyage optimization, EPL, newest ducts, propeller boss cap fins. The next thing that they choose is air lubrication because it's the next best value for money energy efficiency technology that's ready and proven and de-risked.
So, Jessie, what are the big trends for EET adoption? Oliver kind of mentioned some of this already, but are there certain ship types that are implementing these at a higher rate? And is there momentum for growing demand as new regulations come into play?
Yes, that's a great question. What we've been seeing are cruise ships and container ship vessels have been the early adopters of EETs, largely driven by their high fuel consumption, emissions exposure, and public visibility, all of which make sustainability a core business priority. We're now seeing that momentum spread across other segments like bulkers, tankers, roll-on, roll-off vessels as the regulatory and economic incentives align. With regulations from the IMO and EU, such as CII, EEXI, Fuel EU Maritime, and ETS coming into force, ship owners are increasingly viewing EETs not just as optional upgrades, but as necessary tools for compliance and competitiveness. Many of the off-the-shelf technologies have now matured, giving owners confidence in their performance, installation processes, and lifecycle costs. Technologies like low-friction hull coatings, optimized propellers, and variable frequency drives are seeing wide adoption rates due to their relatively low capex and quick payback. On the other hand, solutions with higher upfront investments, such as wind propulsion technology, battery energy storage systems, and air lubrication systems, are gaining ground through phased implementations, pilot projects, and incentivized programs. We're also seeing that EET ecosystems expand beyond ships. For example, shore power integration is gaining traction as ports participate in green corridor initiatives and work to align with ship-side sustainability goals. Mechanisms like banking, borrowing, and pooling under Fuel EU Maritime and the IMO's GFI framework are accelerating this trend. These offer flexibility and economic advantages, allowing early movers to benefit while giving others a pathway to compliance through collaboration or cost sharing.
So, Jessie, sticking with you, how is Class involved in the ongoing development and adoption of EETs? How is ABS supporting companies like Silverstream and the ship owners who want to implement these technologies?
ABS is playing a critical role in both the development and adoption of energy efficiency technologies from the technology side. We support technology providers by guiding them through the regulatory landscape. That includes helping them align with safety standards, choosing appropriate materials, conducting rigorous testing, assessing performance claims, and navigating the type approval processes. We're often involved in hazard identification and mitigation as well. On the ship owner and operator side, ABS offers a range of advisory services through the sustainability and technology teams. We help clients with tracking and managing their emissions in line with evolving regulations, develop fleet-wide emission reduction strategies, whether through retrofits, new builds, planning, or a combination of both. Simulate the impact of various EETs to give owners confidence in the real-world performance of their investments and conduct lifecycle costs and techno-economic assessments to support sound, data-driven decisions. So whether it's a large ocean-going cargo vessel, cruise ship, or a vessel operating in more sensitive or regulated environments like the Great Lakes, we tailor our approach to meet the customer's unique operational and commercial needs. ABS is also deeply involved in every stage of the EET adoption journey, from early-stage concept development and approval in principle to onboard installation verification and post-installation performance monitoring. So ultimately, our goal is to serve as a trusted partner supporting technology developers and ship owners alike as they navigate this complex regulatory environment and compliance.
So, kind of pivoting a little bit here, Oliver, this is something I'm pretty interested in. What's the installation process like for air lubrication? And, since we mentioned those middle-aged ships earlier, is it well suited to retrofits, or are there a lot of new builds implementing it as well?
Retrofits are really popular. With careful planning and a focused schedule, the installation can be done in as little as 10 days. The Silverstream system has never impacted the critical path of the 25 retrofits that we've completed to date, and that's across various segments, various shipyards since our first installation in 2014. So we've accumulated a lot of experience along the way to do this. Time in dock does get a lot of focus naturally, but this work can be completed in as little as 6 to 7 days. What it involves is the ARUs, are patented air release units, I should say. Those are steel units that are the key to our efficient air delivery, and they are welded into the double bottom, sitting flush with the outer shell. Screw compressors are our air source, and they're typically located in the bosun's store. Again, that can be done when the ship is in dock or whilst alongside. There's also pipework and cabling, and that has to be integrated. We'll work with the owner and the yard and the integration engineering company to find the most efficient schedule of works in consideration of everything else that's happening during this special survey. From a new building perspective, this is like any other equipment. So we will follow the installation schedule of the shipyard. Typically, the air release units being steel are integrated at block phase, sometimes at panel phase, pipework, cabling, etc., integrated at the different outfitting stages. As I mentioned before, we've now done more than 120 installations, 25 of those being retrofits. We expect to see more retrofits coming through. We know, particularly in certain segments where the segment is facing high new building prices and there's a lot of structural life left in the ship, there's a strong case for improving efficiency. And we're a mature technology that's present in many segments in the context of this new regulatory landscape where there is a cost to emitting more. It's not just a score anymore. There's a financial implication that supports improving the efficiency of these ships. So we do expect more retrofits to start coming through and balance that out.
So kind of sticking a little bit on the technology itself, what about operating in different waters? Are there certain settings, muddy waters or particularly, choppy waters that may cause problems?
Well, I don't think we should let muddy waters muddy the idea of how air lubrication works. We're a drag reducing technology, right? So the bubbles are reducing the friction of the hull. Regardless of the water, you're going to have friction. We reduce the friction. What affects the savings is how big is the flatter bottom area as a proportion of the total wetted surface area, the prevailing draft and the prevailing speed. So larger, flatter bottom areas, lower drafts because of the hydrostatic heads, and higher speeds, you'll start seeing savings closer to the 10%. That said, even at lower speeds with small, flatter bottom areas, we're seeing decent savings, 5% or so. We've had ships on the water for more than 10 years now. We have a very good understanding of how our system is working. We're not seeing degradation of performance in Beaufort states below Beaufort 7. So up to and including Beaufort 6, we're not seeing a deterioration in performance. And for other operational reasons, generally ships are trying to avoid sustained periods of Beaufort 7 and above. So together, we're seeing very reliable performance, repeatable results, and this has been verified by trusted partners like ABS, ship owners and charterers.
So, Oliver, you've already mentioned kind of some of those other EETs and, where things kind of fit together. Ship owners are usually considering multiple options. So how does air lubrication fit in that broader ecosystem? And what challenges are ship owners and charterers facing when navigating all those different options?
So air lubrication, as you can sense now, is applicable to all vessel types. If the ship has frictional resistance, air lubrication will reduce that. There are, as mentioned, around 650 commitments to ALS as one of the technologies that's considered more novel. It's certainly well established and it's got good adoption rates. Silverstream is present in various segments. When you compare it to what seems to be getting a lot of press at the moment is wind. There's around 140 total commitments between 10 companies over a 10-year period. So it's not necessarily comparable like for like when you think about technology readiness. Air lubrication has become a very popular selection. It's standard, as mentioned, in LNG, very much standard in containers as well. The challenges that we see ship owners and charterers trying to overcome when they're considering an EET, because they've done voyage optimization, they've got some paint, they've done EPL, what next? We see them categorizing it as follows: technology readiness, and I think Jessie and I have talked about that quite a lot, but when we look at technology readiness, what references are there for the technology that you're selecting? What performance validations do they have? And how can you be sure that you're going to get the results that the OEM is putting in front of you in the office? Because at the end of the day, that's what's going to count, even more so when we look at the cost of emissions. Ease of installation, big factor. If you go with a less mature technology, you might start coming up against delays in dock, and time is money, as we know. And then we look at the third part to technology readiness is the in-service element. So you've selected a ready technology, you've installed it. This technology is going to have to last the life of the ship. And anything that can fail will at one time fail at sea. You need someone that's going to partner with you and address those challenges and support the resolutions. We constantly see owners and charterers assess us against how many staff we have, how many operations staff we have, what does our in-service support team look like. Pleased to say that We're now more than 130 staff across 3 offices, and we have the capabilities to support various fleets globally in any port. Those are my 3 points on technology readiness. Commercially, we've seen a shift. We used to get a lot of questions on how the technology works, why does it work, what are our references, but now increasingly the conversation is shifting between charterers and owners on who's going to pay for this. But if you can have certainty on performance and you've de-risked the technology through the 3 points I mentioned before on readiness, ease of installation, in-service support, etc., you're in a better position to address what we call the split incentive, where the owner is going to own this technology, but primarily the charterer is going to benefit from fuel and emissions intensity reduction. That said, as Jessie pointed out, there are benefits for the owner as well. Remember, improving the efficiency of your vessel keeps it competitive, keeps it current, it gives you flexibility, it stops you having to pull the trigger early, or at least delays when you can pull the trigger on a fleet renewal program. But normally those are the aspects that we see owners and charterers debating and considering when looking at air lubrication and other EETs.
The magnificently complex nature of our industry and all the different stakeholders and who gets to say so in different things is, it's always really fascinating. So, Jessie, sticking to that point, how is ABS helping ship owners, evaluate the multitude of EET options?
This is where ABS's technical depth really comes into play through our sustainability centers and simulation and technology teams. We can help ship owners evaluate the full range of EET options using data-driven, asset-specific analysis. While many technologies promise strong efficiency gains, the reality is the performance can vary depending on the vessel type, size, and operating profile and trade routes. That's where oftentimes decision-making can get difficult, and we can help by doing analysis and running scenarios. We use proprietary simulation tools that model real-world vessel conditions to project fuel savings, emission reductions, ROI, and life cycle costs. These tools allow owners to see how a technology can perform for their specific fleet, and not just in theory, but in practice. Let's say a ship owner is considering a dozen off-the-shelf EETs with statements of 1 to 5% savings. On paper, this can be very attractive, but we need to be able to analyze the technology specific to the vessel operating conditions to be able to appropriately assess the benefits. Our role is to help identify which technologies will maximize impact and which ones may offer diminishing returns. Ultimately, it's about making the right decisions at the right time and on the right vessel assets. We aim to be a trusted partner throughout that process to help owners move from uncertainty to more confident, informed action.
Is there a point of diminishing returns when you talk about having all of those options, whether you're adding too much weight or taking away cargo space? Obviously, ALS doesn't really do much to either of those points, but when you're incorporating it into that ecosystem, Oliver, have you seen pushback as far as, there's too much stuff that we're incorporating?
Brad, it's a very interesting question. I think it calls to one thing I wanted to bring to this audience, which was collaboration is key. So there are plenty of technologies out there. Some are more ready than others. But if you look at harmonizing the technologies together, you're going to get more out of your ship as a system, as opposed to taking a perfect vessel design, in inverted commas, and then adding on a few extra things to make it even more perfect. You've kind of skipped a few steps in the design spiral there. So I think as part of my advice to anyone considering EETs is look at everything together holistically, not in series. And for sure, you will get more out of what you're trying to do with the ship, which is reduce unit freight cost, improve efficiency, reduce your exposure to emissions, etc.
So, I always like to ask our guests to predict the future. So, Oliver, where do you see EETs going in the future, say 2040, 2050? Do you think there's some untapped potential the industry hasn't quite figured out yet?
In the crystal ball moment, I think we can all expect a greater emphasis on efficiency. The cost of emitting is increasing. Transport work demands are also going to increase on the global fleet. So if you can improve efficiency, you can take the sting out of emissions compliance and your fleet can do more work for the same emissions output. Surely by 2040 to 2050, as we've seen already in some segments, off-the-shelf mature technologies that have high technology readiness today are going to be standard across all segments. The real untapped potential, as mentioned, comes from collaboration in the design phase. And I think when you look for collaborators, you need quality OEMs with a range of experiences over a long period of time that can bring those experiences to the table with references from various segments. They're not just basing their experience on a couple of installations in one segment over a short period of time. You need the depth and the bandwidth in these OEMs to get the best collaboration between them all. Consider that ship as a system as a whole, including all of the EETs. In the meantime, Silverstream Technologies will continue to improve our products as we've done so far, so that owners and charterers are always getting the best system available to them from us.
And Jessie, what do you see in the future for EETs?
Looking ahead, EETs have a key part in playing in regulatory compliance and broadly improving efficiency. They're not just transitional tools. They're long-term enablers that will continue evolving alongside regulatory, commercial, and operational demands. While the industry has historically been slow to adopt change, that's shifting rapidly. The push for reduced emissions driven by regulations and market forces is accelerating innovation. We're seeing a growing appetite for technologies that enhance efficiency, extend vessel lifespans, and reduce emissions, all while keeping cost manageable. In the future, we'll see today's off-the-shelf EETs fully integrated into next-generation ship designs. At the same time, new innovations are emerging across the board. There's autonomous hull cleaning robots, advanced coatings, onboard renewables like wind and solar, hybrid energy systems, and smarter digital control systems. And while alternative fuels get much of the spotlight, EETs will remain essential companions, helping bridging the gaps, reducing total energy demands, and improve fuel flexibility regardless of what propulsion system is used. At ABS, we see this as an exciting space for continuous collaboration, supporting both the innovators developing new solutions and the ship owners making smart strategic investments. The future of EETs is not just promising, it's pivotal.
So, wrapping things up here, I was wondering if each of you had some closing thoughts you'd like to leave with our listeners. Maybe one big takeaway about EETs or air lubrication. Jessie, you want to take that one first?
Sure. The maritime industry is undergoing one of the most transformative periods in history. Achieving the IMO net zero targets will require the right balance of future fuels, next generation ship designs, and critically, the widespread adoption of energy efficiency technologies. EETs are not just complementary, they're central to making this transition achievable, scalable, and cost-effective. Technologies like air lubrication systems are proving that innovation can deliver tangible results and that performance and sustainability can go hand in hand. What's most encouraging is the growing sense of collaboration. Regulators, ship owners, ports, and technology developers are coming together in ways we haven't seen before, and that's exactly what this challenge demands. At ABS, we're proud to support every link in the value chain with the technical guidance, tools, and expertise to help turn ambition into action. Of course, the pathway isn't a one-size-fits-all. Considerations like CapEx, ROI, regulatory compliance, and whether you're upgrading an older vessel or investing into a new build all comes into play. But with the right strategy, these technologies can offer both environmental and commercial value, and we're here to support that transition.
And Oliver, any closing thoughts from you?
We've heard collaboration a lot today, and that's one of mine, but in two parts. Collaboration from a technical perspective with ships as a system. Like I mentioned before, harmonizing the integration of various technologies, not just energy efficiency technologies, but in the whole ship as a larger system is going to yield even greater results. And as essential companions to your compliance journey, the long-established, mature energy efficiency technology providers are well placed to bring capability and experience to support those discussions. Second part on collaboration, split incentive gap. Collaboration is needed there, but it's easier to achieve through technology de-risking, both on the technology itself and the credentials behind it, but also ease of integration and in-service support. Knowing that you're going to get those savings, that it's not going to delay you, that you'll keep getting those savings through life is going to help those commercial discussions between the two key parties, owner and charterer. Lastly, to anyone who's interested, we've peaked today on air lubrication. If you want to know more, then don't hesitate to reach out to us.
Okay, great. Well, Oliver, Jessie, thank you both for joining me on this episode of Setting Course. We had some great discussion about how EETs are making waves in the industry. So This is one I'd certainly love to revisit in a few years as the industry continues to innovate and pushes the envelope on efficiency. Thank you both for being on the episode.
Thank you, Brad. Really enjoyed it.
Thanks so much for having me.
And for everybody listening, thank you for joining us on another episode of Setting Course. Be sure to subscribe, leave a review, and share this episode. To learn more about energy efficiency technologies and maritime sustainability, visit us at www.eagle.org. Thank you for listening.